Yeah, I would. It would make me feel better. Okay. All right, guys. So here we go. Hashtag need coffee. Bless you. Uh, oh, happy birthday, Gonzaga. Happy B day. So how old are you today? 15? That was a joke. She knows I was joking. Guys, obviously, I know 17 or 18, one of the two. Yeah, she knows. Oh, right, one of those two numbers, right? See, we're good. Yeah, probably. Okay, sorry, YouTube. I promise that I am not a bully to any of my kids. No, I'm not. All right, so we're doing today's stuff, guys. Analysis of functions. You guys actually already know this. You probably don't know that you know this, but you already know this. It says so. Let's see what it says here. Intervals where the function is increasing or decreasing. F is called increasing on a given open or close if any x1 and x2 on the interval such that x2 is bigger than x1. That's just math notation. So the y value at x2 is bigger than the y value at x1. Chop, what does all that mean? I don't understand. That means this. I have a point, I have another point, and it goes along the curve. Well, obviously on this curve, see how this point's lower and this point's higher? All this means is you read a graph left to right. If you read a graph left to right and it's going up, the function is. If you read a graph, and then the next, it says f is called decreasing on a given interval if x1 and x2 on the interval such that x2 is bigger than x1, and the y value at x2 is smaller than the y value at x1. This is just math symbol to say that you read a graph left to right, and if the graph is going down, you are. That's all it is. That's all that notation is. There's a new word. This is Latin for those of you that are studying Latin. Extrema. Extrema is a fancy word for extreme, and we use that to indicate max or min. So if you hear something, if you see a question that says, find the extrema, it's saying, what are my max and mins? Cool or not cool? If you have a closed interval, there's a theorem called extreme value theorem, and I know that I did a bad job, and I forgot what year it was. It might have been 2023. It was just one part of a free response. One of the free response questions said, prove that a function has a maximum. And usually to prove that a function has a maximum, you have to do like a critical point test. Don't worry, we're gonna learn all this, or a candidates test. But this question didn't have any of that. All you had to say is that it was a closed function, and every closed function by the extreme value theorem has to have a max and min. So don't worry, I'm about to tell you what it is. Look what it says here. Here's the definition in quotes. If f is continuous on a closed interval a to b, then f has both a max and a min value on the interval. So all it's saying, if you have a closed interval, any function, any closed interval, you have a max and min. And I know some of you maybe are thinking, what about a horizontal line that's closed? What about a horizontal line that's closed? Does that have a max and min? Yes. I know what you're saying. You're like, Chop, how does that have a max or min? Every point on that horizontal line is a max and that's a special case. But the AP exam, or any exam for that matter, with your professor, they probably will not give you a horizontal line unless they're really trying to mess with you. I don't know, maybe you have a professor at U Chicago that might try to mess with you and to ask you. There was actually a discussion. Does a horizontal line have a max or a min? And okay, I'll let Miss Alvarez talk to you guys about that whenever, if you bump into her or whatever. All right. Hello, Miss Alvarez. If you're listening to this YouTube video, I'm gonna send it to her. So now she's gonna hear it. I'm gonna go to the 10:40 mark. Hello, Miss Alvarez. LOL. Okay. All right. It says let's draw out some cases and see if the extreme value theorem applies. You guys ready? So I'm just gonna draw some random stuff. Let's see, what am I going to draw? I'm going to draw this curve. I have a closed. Does the extreme value theorem apply? Yes, I have a max. The max is right there. I'm going to call that an absolute max. And I have a min. Absolute min. It doesn't. It just, there's just more stuff that happens to it, but it won't. What's up? It's the highest point in the curve. Yeah, we're going to talk about that. Don't worry, miss. We're going to talk about all that. All right. Let me draw. Now, just because the extreme value theorem does not apply does not mean that I don't have a max or a min. So leave this one open and close. Does the extreme value theorem apply? No, because I am not continuous. It needs to be, well, open circle on the A means that I'm not continuous on my interval A to B because of the A there. But I do have a max.
So extreme value theorem is an interval. It's not just like a singular point.
Oh, extreme value theorem just says that if you're close, you have a max and a min for sure, guaranteed. Now, this one does have a max, but do I have a min? Nope. It doesn't have an absolute min. No absolute min. I do have something now. Teachers, I'm saying teachers because there's a few teachers that might look at my video here. Teachers, if you have a textbook that does not tell you anything about your endpoints being relative max and mins, then disregard this. It just depends on what textbook you have. In my opinion, this is just my opinion, depending on what textbook you use, it might be different. This does have a relative min. What does a relative min even mean? I'm talking about locally in the area.
So it'd be like right before.
Yeah. Right before, no. The A, you don't even look at that. Look at the B, right at X equals B. That is what I would call, this is what I'm calling it, a relative min. Chop, why? In the vicinity, check it out, Miss Houston. In the vicinity, this is the lowest point. Any other point on this curve is higher than this point. Does that make sense? So I call this a relative min. Is it an absolute min? No, because it's not. It's absolute means lowest or biggest, I guess. Absolute min means lowest. Do you guys know what I'm trying to say?
Yes. Okay. So if A was closed and B was open for
then it would have an absolute min and an absolute max. That's a good one. What's up?
So is it like because it's not continuous on like the A, then we just disregard everything past the absolute max, or?
No, because I have an open circle on A, I just don't have an absolute min. Because
like why is it in B and not just like along the A line but not next?
Well, because I don't at B I stop. I'm not stopping. Like you can't call A a min. Like what pixel? Like you know what I mean? Like A itself is a singularity. It's open. Like nothing exists there. And then how close are you going to get to A? 0.1, 0.01, 0.001? There is no stopping.
But more so like how could we not say like this point does exist, or we saying that's not relative?
Well, because I have another pixel that's lower.
Oh, so it's
In the vicinity, yeah.
you said you were at here.
No, I'm not ignoring.
Don't
But I
touch
can't
me,
call
Noel.
this a min because I have another pixel that's lower. I can't call this a min. I have another pixel that's lower.
Dang, that was that and
We
everything.
can't because it's relative close to the vicinity. There's other pixels that are lower. Yeah, I'm looking here. There's no other pixel bigger. So that's the max. Here, there's no other pixel in the vicinity lower than this. All right, here we go, guys. Extreme value theorem does not apply.
Stop, I'm tired of you.
Hey, relax, guys. I'm gonna have to edit that out because they're gonna say, "What's going on in your classroom?" Right. Is what? Yes. All right. That's what we're gonna get to right here. Let's chat the difference between local min max and absolute min max. Local and the word relative are interchangeable. Try and guess. What do you think is the interchangeable word for absolute?
Always?
Starts with a G. You heard it before. What'd you say? No. Second letter L.
Low? Right.
Third letter O. Global. Who said global?
Oh, I
Yeah.
said low. I said
Global. Global and absolute are interchangeable because we're here on Earth. We're in a globe. So context clues global is the same thing as absolute. So they're interchangeable. If you see something, what's the global max? That means what's the maximums of all maximums, the highest point, period. If you see global min, then that's the smallest point, period. Not all relative max and mins are global, but all globals are also relative. Let me say that again. Yeah, let me say it again because it's a play on words. Not all relative max and mins are global. There can only be one for global or for absolute. But all globals are relative because in the vicinity, that's the highest point or the lowest point. Does that make sense? Okay. If you have colored pencils, this would be a good place for colored pencils. Look what it says here. It says observe the behavior of f prime. All right. Before I tell you guys the behavior, do I tell you anything here? I don't. Okay. Put this on the side somewhere in the bottom. I'll write it in red. I'll write this in red. What does this mean? F prime greater than 0. What does it mean about f? Okay, the slope of f is greater than 0, right? If the slope is bigger than 0, that means the slope is positive? If the slope is positive, what does that mean about f? That f is what? Increasing. Perfect. So I'm going to write this means f is increasing. And then I'm going to write the other one in blue. You don't have to choose red or blue, just different colors. If f prime is less than 0, use context clues. What do you think that means about f? Perfect. This means f is decreasing. All right, so I'm going to use red and blue. Between a and x1, is f prime positive or negative? So I'm going to write f prime greater than 0. I'm going slow, guys. I'm going slow. Between x1 and x2, is f prime positive or negative? Negative. F prime is negative. I'm slowing down. Between x2 and x3, is f prime positive or negative? Positive. Between x3 and x4, is f prime positive or negative? Positive. Between x4 and x5, perfect. F prime is negative. Between x5 and x6, positive. Between x6 and b, positive. So catch up to here. I want you guys to notice something. I guess let's label what this is here. X1 is, let's use the word local or relative. It doesn't matter. X1 is a relative max. They're all relative. In a little, let's just label them all relative. In a little bit, we'll talk about global. X2 is a relative min. X3 is nothing, so don't label X3. X4 is a relative max. X5 is a relative min. And X6 is nothing. And then we'll look back at A and B in a little bit, but for now, those are the big ones. You know what? I'll just go ahead and label them already. What's up?
Is it like we're using two like lines that like 2 inches determine whether or not it's relative?
No, if it's the highest point in the vicinity, it's a max. If it's the lowest point in the vicinity, it's a min.
I'm saying, are we trying to make vicinities based off just like conversion lines? Oh, it's good. I don't agree.
Based off of F prime? Oh, we're not there yet, but you're getting ahead of me. A, don't worry once I see you. A is for now, a relative min, but maybe we won't emphasize it as much. And B in the vicinity is also a relative max. Now, if you Google, you might find a text that says that you can't be relative at an endpoint. It all just depends on what textbook you use. Our textbook, if you check out our textbook, the Demanda textbook, you can be relative at an endpoint. Our textbook.
Will we ask this on the exam?
On the AP exam, they avoid any type of ambiguity. They will ask where's the global max, and you can be a global max at an endpoint.
That's
Yeah. What was the question, Ms. Henderson? All right. Look at where you have relative max and relative mins besides the endpoints. Look what's happening. Look how I'm changing colors at every max and min. Do you guys see that or notice that? So notice that I have a max whenever my derivative changes from what to what. Yeah, and it makes sense because if you're positive, you're going up, and if the f prime is negative, you're going down. F is going down. And this is the place where you got to be very careful with your words. Try not to use the word it. So you say if f prime changes from positive to negative, f has a max. If f prime changes from negative to positive, f has a min. So let's write that down somewhere. Where do I write it? Right here. So I'm gonna put it right here. I'll put it in a neutral color. Bullet. If f prime changes from positive to negative at x equals c, semicolon or comma, x equals c is a relative what? Max. Because you're going from positive to negative. Think about it, left to right. Positive, f is increasing. Negative is the relative max on f. There we go. Now it's 100% correct. If f prime changes from positive to negative at x equals c is the relative max on f. Now we're 100% correct.
Because we're not sure if we have like a set value for each.
Yeah, x equals c is just some number. If f prime changes from positive to negative at that number, then at that number, that x value, I have a relative max on f. See? Positive to negative, max. Positive to negative, max.
Oh, so there's a relative min.
No, the other way around.
It depends on what starts from left to right.
Yeah. If f prime changes from positive to negative, I wrote it. If f prime changes from negative to positive, then I have a min. I don't know if I have enough space for the min one. All right, let me label this really fast. Where is the biggest maximum? At x4, so put global max. And where's the biggest minimum? So at x2, put global min. What other word can I use besides global? Absolute. Don't worry, we're about to. I do want to put the other one too. Okay, let me put the other bullet. I'll put it up here because I don't have enough space. I'll put it right here. If f prime changes from negative to positive at x equals c, comma, x equals c is a relative what? Min. On what graph? On f. Try to avoid using the word it. I can't tell you how many kids have lost points saying the word it. And I have to grade it that way. I can tell the kid knows calculus, but they write something like f prime changes from positive to negative, comma, it has a max. What is it? Especially if usually they give you like 2 or 3 different curves, f, g, and h. We don't know which one. I know he's talking about F, or she. I don't know who the gender is of the test, but I know they're talking about F. But because they wrote the word it, no credit. You got to be specific. If f prime is positive, f is increasing. So if f prime changes from positive to negative, f has a max. Does that make sense, guys? All right, let's see what we got here. All right, for the longest time, Dr. George, I don't know where you're at, Dr. George, but wherever you're at, or she's at Georgia Tech. I don't think she's gonna listen to my video. Maybe I'll send it to her also and tell her go to 1057 and all right, I'll stop. For the longest time, I called f prime equals 0 and f prime prime equals 0 a critical point. And then Dr. George was like, the second derivative equals 0 is not a critical point. I'm like, Dr. George, I know that. It's just a play on words. A critical point just means something's happening. Maybe something's happening when the second derivative is 0. Trying not to get too ahead of myself. She was like, no, this is what a critical point is. So I'm like, all right, fine. I think they're just words to mean, obviously, stuff. We'll be technical. A critical point is only where f prime is 0 or f prime does not exist. What does a critical point mean? Maybe there's something happening there, maybe not. Look at this graph here. Notice that all the max and mins happen where f prime was either 0 or f prime did not exist. Chav, what are you talking about? Look, notice or observe. Right here, when it goes from positive to negative, notice that f prime is 0. Do you guys see that? Notice at x2 that f prime is 0 as well. Do you guys see that? But notice at x3, f prime is 0, but did it change? Is that a max or a min? No, there has to be a sign change. So a critical point just means maybe it's a candidate for a possible max or min. You got to check if there's a sign change. If what's a sign change on f prime? We're okay? Okay. Does that make sense, guys? All right, so there it is. That's what a critical point is. And then remember, look what it says. Put a bullet right here or a star. F is increasing and f prime is positive. F is decreasing and f prime is negative. You always read a graph left to right. So I'm going to put that in here. Read a graph left to right, just like you read a book. Sorry. I don't know what country it is or what language it is, but there's a language where you read top to bottom. Is that Japan, Chinese, or Mandarin, one of the special ones? And then is it top to bottom and right to left? Yeah. What is that Mandarin? A special form of Mandarin? Oh, so all of Japan? Okay. If you're in Japan, maybe this is hard. I don't know. But you always read a graph left to right, just like you read a book. Sorry, Japan. Okay. All right, here we go. Corollary 1. We're not taking, obviously I took this from a textbook. Let f be continuous on AB and differentiable on AB. We already know this. We already know. They're just being technical. Look what it says. If f prime is positive on each point on AB, then f increases on AB. If f prime is negative at each point on AB, then f decreases on AB. We already know that, guys. All right, now we're going to draw. Are we okay so far, guys? Do we still have the energy to keep going? If f prime changes from positive to negative at C. Okay, so let's do that. I'm going to draw a little grid. I'm going to say here's C. And I'm just going to make one where f prime is 0, and I'm going to make one where f prime is undefined or does not exist. So here it is. Here's A, and here's B. And then I'm going to do another one. And here we go. Oh, it doesn't matter, miss. I'll keep the color change that I had before. And let's see, how am I going to do it this time? I'll do a little bird. That's how I used to draw birds in elementary. F prime is positive. What's a better word? Undefined? Does not exist is fine. Okay, are those good notes? This is a graph of F. So if F prime changes from positive to negative at x equals C, what do we have? F has a what? No, don't worry about absolute. F just has a max. Write that down. F has a max. If F prime changes from positive to negative at x equals C, or at C, F has a max. And look, there it is. Those are my visuals. Cool or not cool? Cool. Oh, okay, all right. I'm still here, miss. I thought I was done with my Dr. Pepper, and I just looked, and I still have some, so now I'm back to happy. I mean, I'm happy, period, but I need the caffeine, you know? I need an IV with caffeine and just infuse into my vein here. You know, it's been a long time since I've seen caffeine pills. In Nevada, they have caffeine pills in gas stations. You can just. I'm sure there's a warning, like, don't take more than so many capsules or whatever. All right, here we go. Number 2, F prime changes from negative to positive. Do you guys want a visual? All right, here's my visual. I'm going to call this F. I'm going to call this A. And here's my visual. It doesn't have to be perfect. I'm going to change it right now with colored markers. There's C, and so let me go ahead and write. Here's my point. Sorry, that's B. And then this is C. No, there's no trick. F prime is negative. Oh, eventually, yeah. Yes. Yes. All the time. All the time, miss. There's extreme value theorem at work. So let me do, what did I say now? I'm going to do a bird, but the other way around now. Don't worry, I'm going to color code it in a little bit. This is already red. There it is. If F prime changes from negative to positive, what do we have? F has a min. You okay, engineer? While you guys are doing that, take another sip of my. How many milligrams of caffeine do you think this has? You're 1 milligram away. 68. Good thing it was not 67. Because then the whole class would be. Then Mia Cruz would explode and be like 6'7". All right. If F prime does not change signs, all right, here we go. F prime does not change signs. I'm going to go ahead and do it like this. Oh, no. It doesn't go forever. It's at a closed interval. A. B. C. That's an A there. It just came out bad. and all of it's red. This is F, and look at that. F prime is positive. I'm increasing. Look at this. F prime is positive again. Right at that moment, F prime of C is 0. I'm going to draw another one. Do the same issue. Let's see, how am I going to do it? I'm going to do it like, I'm going to do that, and I'm going to do a corner. What the heck? That's how you sound this. Sorry. I do not bully my kids, YouTube.
What's up?
See, you just activated their stick.
I should have done one where it was decreasing instead of, oh well, I already did that, so too bad.
You should have done one that has six.
Yes.
Could it also be a horizontal line or no? With 3 points?
Oh yeah, yeah. A horizontal line is neither increasing or decreasing ever. So, but then comes, do I have a max or min? We're not gonna. Let's not go there. We'll let your U Chicago professor take care of that.
Are you a big advocate in Chicago?
I do love U Chicago. That's a good university. I'm gonna go there in February. Oh yeah, I did.
Yeah, you're gonna buy this. So what's FC?
Just for a day. F prime of C in this case does not exist. Because see how it's a corner? What do we call if the derivative is 0 or undefined? There's a word for it, a vocabulary word. Starts with the letter C. What did you say? Critical point, yeah. Here it is. It's called so what does it mean if the derivative is 0 or undefined? You're going to say that's a critical point. I should use does not exist better. All right, how do we feel? If the derivative is 0 or does not exist, that is the definition of a critical point. All right, these are special cases at a left endpoint and at a right endpoint. I'm going to let you guys decide if you guys want to talk about them or not. Should we talk about them? Okay. Draw this real quick. Don't worry. You're fine.
Every time you say don't worry, you're fine, I get like chills because every time you say that, like
Oh. See how it says x is greater than a? So start at a. And this says that f prime is less than 0. So here we go. I'm just going to go f prime less than 0. That is the highest point in the vicinity. Do you guys see that? So we are going to call this a relative max. Are we okay? Oh, it could, what if it would have done this? If it would have gone like that? It's no longer the absolute max because look, there's other points that are higher. Do you know what I mean? So we're just going to call everything relative. Or it says x greater than, so I'm just going to put an arrow. We don't know what happens to the right of that. Cool. All right, look at number 2. It says if f prime is greater for x is greater than a, so here we go. This was f, by the way. F and f. And here is a. And f prime greater than 0 means I'm increasing. Well, you know what? I already started, so too bad. This is a relative min. And you were right, Bernal Sierra. There, if I give this restriction, you might be able to also call it an absolute, but we don't have enough experience yet. Yeah, because if we have that restriction, then I can't be going up forever.
so is it like I guess positive functions gonna have only the relative? I guess it has to be like that's only that's basically positive bond, that's basically.
Oh, but you'll see later on. We might not even talk about it if it gives us a hard time, because we always have to check our endpoints also for max and mins, especially for global, but we don't always check them to see if they're just max mins in general. So we'll see. We'll see how we do. All right. By the way, that's a left endpoint, guys. So underline left endpoint. See, that's a left endpoint. The next one, notice this is a right endpoint. At a right endpoint B. So here it is. Here's B. Notice it says x less than b. Are we still okay? This function is decreasing. So here I am decreasing.
How is the endpoint if it's less than and not less than or equal to?
Yeah, this is b. And all these x values are smaller than b.
Yeah, but I'm saying how is the endpoint defined? Because it's x less than.
It just says endpoint b. And then I'm looking at my domain where my x values are smaller than b. But it's telling me, remember, we always read a graph left to right. So this graph is decreasing. You know what I mean? Maybe I worded it wrong. Maybe I should have put like semicolon or something.
No, I was just asking because
Oh, this is informal. Go ahead, ask me.
because it's like x less than b instead of x less than or equal to b.
Oh,
It's not defined.
less than equal to. You know, maybe it's my mistake, miss.
No, I was just asking. I'm not trying to.
No, you can ask. You can ask all you want. You can ask all you want. Yeah, I like that graph better. No, you guys can leave the graph, but as long as it's decreasing, was it decreasing or not? Yeah, this is that. This is that. As long as you're decreasing, notice this is a relative min. I know we got some teachers that maybe are looking at this and you can't be relative at an endpoint. Well, that's what your textbook says. Stop. Here's my endpoint, B. This is F. This tells me that as long, let me put the equal sign, make sure everyone's happy. It tells me, stop, we're good. As long as X is less than B, I am always increasing. There it is. What is this? Relative max. Maybe we'll talk about them. Maybe we won't. We'll see. To indicate that you keep going. Oh, I mean, I could. It doesn't tell me anything about A. It just says at a right endpoint. So at the right endpoint, I'm stopping. I'm not putting an endpoint. I'm not putting an arrowhead on B, right? We know that. Because they're endpoints. All right, here we go, guys. Let's do some problems. This would have been a good one for a poll, but that's fine. Not a big deal. All right, here we go. For what values of x does a function have a relative maximum? Obviously, I know, guys, if you were in algebra, you would probably just graph this and then graph it, and then wherever you have the highest point, you would call that a max. But if we don't have a graphing calculator, you just have this. No calculator. How would you do it? Well, I am finding where what? Where f goes from increasing to decreasing, or wherever f prime changes from what to what. So I need my derivative. So I'm gonna I'm gonna put steps because some of you guys told me I want steps in your notes. Like, okay, here you go. Find f prime. All right, let's find f prime. What rule do I need? Product. F prime of x equals first times root of the second, 2 parentheses x minus 3 close it to the power 1 times 1. So there it is. Plus second, x minus 3 close it squared times root of the first, 1. Are we still okay? All right, we're going to have to do some algebra. Relax. 2, x minus 2, x minus 3, plus x minus 3 squared. I just rewrote it. Maybe you didn't have to. I'm not going to FOIL. I mean, I guess you could, but here's what I see. I see a product on the left with the 2, x minus 2, x minus 3, and then I see x minus 3 squared. What can I factor out? On x minus 3. So big parenthesis. I'm exaggerating that big parenthesis. And then another big parenthesis, and you have 2, x minus 2. Maybe that will distribute a little bit. Plus an x minus 3. Do you guys see what we did? Okay. Now, I'm slowing down. I'm slowing down. Now we're just doing algebra. And then drop these parentheses. So let's see. X minus 3. And I'm trying to go as slow as I can, guys. Is this an okay speed? 2x minus 4 plus x minus 3. I listen to you guys. See, I'm adjusting. Yeah, combine like terms. X minus 3, close, open. What's 2x plus x? What's negative 4 minus 3? Okay. There's my derivative. In order for me to find a relative max, I need to find candidates. So I take my derivative and I equal it to 0. The only way this will be 0 is if x equals 3 or if x equals 7 over 3. And I guess on this one, there's only one answer choice. So if this were a test, I wouldn't even bother. I would just choose 7 over 3. I can't believe I didn't type in a 3 in there. All right, next year, I'm going to put star and then edit for next year's notes. Turn positive. Okay, here's how I would like for you guys to do it, though. Draw a sign chart. The domain is all row numbers. Call this f prime. 7 over 3, is 7 over 3 a number bigger than 3 or smaller than 3? Smaller, yeah, because 9 over 3 is 3, right? So I'm going to put 7/3 right here. And I'm going to put 3 right here. All you care about is where the derivative changes from positive to negative. Obviously, the answer is 7/3, but let's pretend we don't know that. Are we okay? Give me a number smaller than 7/3, any number. Yeah, 2, 1. It doesn't. I was thinking you were going to say 0, but that's fine. 2. 2 minus 3, positive or negative?
2 minus 3 negative.
Negative. 3 times 2, or you guys said 2, right? 3 times 2, 6. 6 minus 7, positive or negative? Negative times a negative. Put a plus symbol right there. All I did, this is f prime. This function is f prime. All I care about is the symbol. Is it positive or negative? Remember, 7 over 3, what's that? That's like a 2.3333333. Give me a number between 7/3 and 3. 2.5. 2.5 minus 3, positive or negative? Negative. 3 times 2.5, Chop, I don't know what that is. 7 point something minus 7. So negative times a positive. Negative. And I know we shouldn't even check the 3 bigger than 3, but I'm going to check it just so you guys can have practice. A number bigger than 3. 4. 4 minus 3. 3 times 4 minus 7, positive or negative? Positive times a positive? Positive. You read a graph left to right. So I'm looking for a max. So I'm looking where f prime changes, write this down somewhere, from positive to negative. All right, where do I change from positive to negative? 7/3. I know, I didn't make that one hard because that was the only answer that was in there anyways. But next year I'm going to change that -3 to a positive. And there's 2 possible candidates. Sometimes it's both. But in this case it wasn't. How do we feel? Not bad, right? Do you feel okay, Ms. Cruz? Can we take some more, guys, or no? We don't have that many left. Oh, I love that one. Okay. All right. Find the intervals on which f is increasing. Well, what's up? I don't know. Let's just keep going at 12. 12. All right, here we go. 11:57. All right, here we go, guys. F increases. Make sure to write these notes wherever f prime is positive. This is how you say f prime positive. Are we still okay, guys? All right, here we go. F prime of x equals, I'm just taking the derivative, what's 7 times 4? Yep. Plus, what's 0 over 4x cubed? You're done. Now you're doing algebra. I'm going to set this equal to 0. What can I factor out? What's the biggest common factor between 12 and 28? 4? How many times does 4 go into 28? 7? So 4x squared parentheses 7x plus, how many times does 4 go into 12? 3. Close equals 0. Here are my candidates. x equals 0, and x equals negative 3/7. I don't see any errors. Make sure that there's no errors. We're going to get what? That's me, because I make mistakes all the time. These are my x values. Railroad tracks. Do I even... Okay, let's be smart, because sometimes you guys turn into robots. Critical thinking. Do I even have to worry about the 4x squared? It's always positive. So just focus on this linear part. Yeah, because it's squared. Write down, always positive. It's being squared. Critical thinking, guys. You don't even have to worry about it. Give me a number to the left of negative 3/7. Any number. A whole number. What's the easiest number in your brain? Negative 1. Yeah. 7 times negative 1, negative 7. Negative 7 plus 3. Positive or negative? Negative. A number between negative 3/7 and 0, like negative 1/7. I would say that's what I would do. Negative 1/7. 7 times negative 1/7. The 7s cancel out. Negative 1. Negative 1 plus 3. Positive. And then a number bigger than 0, it's going to be positive again. So, where are you increasing? Oh, yeah, I remember. We had a talk with Dr. Cannon on this one. All right. F is increasing on bracket negative 3/7, comma, to infinity, since, and don't worry, we're going to have that discussion. This is why I put it here. Since f prime is greater than 0 on negative 3/7 to 0, union 0 to infinity.
So would that still be a relative min or not?
Say it again.
Would negative...
Yeah, because right at 0, you have the derivative is 0. You could have also, let me write an alternate
Do you
definition.
have like a set value for relative min or no?
Oh, we don't care about relative min. There is a value, whatever it is at negative 3/7, but we don't care about it because it's not asking us that. It's asking us where this function is increasing. You know what I mean? Yes, there's a value for min, but we don't care about it. It's not asking that. Did I answer your question, miss? There is an alternate. I don't know if I confused anyone or not. Alternate. You could have said f is increasing on bracket negative 3. This is an x coordinate, comma, to infinity, since f prime is greater than or equal to 0 on this interval. You could have said that, and it's still correct. Yeah. We're going to discuss on this one. Maybe I should have started with x cubed. Real quick, in case I don't know if I confuse anyone. You see, wherever it's positive, f is increasing, right? Right at 0, you're not increasing because you have a horizontal tangent, but you're not decreasing either. You just have a horizontal tangent. Chav, what do you mean? Okay, this is not part of this graph. It just looks similar to it. So imagine x cubed. This is a side note. So don't write this down. Just listen. So imagine x cubed. X cubed looks like this. Yes or no? Notice right at 0, you're not increasing or decreasing. It's flat. But you're not going to say, oh, x cubed is increasing from negative infinity to 0 and then union 0 to infinity. You just say you're increasing in the entire domain. Does that make sense? So this is why, okay, it's fine if you do it this way. I see it done all the time at the reading when I read kids' explanation. Some of my last year's crew, they didn't like to say these in 2 separate intervals because right at 0, it does not equal, like see how this says f is greater than 0? So right at 0, it equals 0. My derivative is not positive right at 0. Does that make sense? So a lot of my kids, what they start doing, they just put the equal sign on the bottom. Like, I don't want to deal with this, Chav. I don't want to deal with that. I'm just going to put the equal sign always and then just say this interval. If that's you, we're not teaching you the test. That's the mirror. If that's you, you can just do that and you'll have it right all the time. What's up? Yeah, we'll look at it right now. Oh, that should have been a bracket right here. The only one that's not a bracket is a 0 and the infinity. What other questions we got, guys? Do you guys want to see that picture or no? Oh, you guys didn't sound convincing. 7x to the 4th plus 4x cubed. I'm going to show you guys something that you're going to like, I think. Don't worry. Did you know that decimals can do derivatives? Give me the function. Give me f of x. This is just the beginning, Miss Houston. You're going to be engineering life. You're going to be doing this in MATLAB. You're going to be writing scripts. So check it out, guys. That's my f. Check it out. Right at 0. See how you start increasing after you pass this point right there? There it is. I bet you that is that number. What was my negative 3/7? So look, negative 3/7. I bet it's that. Negative 3/7. And look at that. So let me push. Look at that. That point is that point. Isn't that cool? Now check it out. Look at this. You see how I labeled f prime? I mean f of x? F prime of x. Look, that's my derivative graph. If it's above the x-axis, it's positive. Notice that it's below the x-axis until that point, and every time else, it's always positive. Well, right at 0, it's 0. Isn't that cool? Okay, we're not there yet, though, but we're so close to being there. Cool or not cool? Are you not entertained? Okay, can we take some more, guys? Okay, we just got 2 examples left, and that's it. Find the intervals on which this is increasing. Okay, so I don't have any vertical asymptotes, so I don't have to worry about that. I'm just going to take a derivative and equal it to 0. So your algebra is going to be working hard here. F prime of x, I got to do what rule? Quotient bottom times root of the top. What's the root of the top? Plus or minus? Minus top times root of the bottom. What's the root of the bottom? All over. I'm going to equal this to 0. You do not have to pay attention to the denominator. You just got to pay attention to the numerator, because the denominator will never be 0 or undefined. Like you'll never get x squared plus 49 to equal 0, because it's a plus. It has a plus on it. And you don't even have to worry about it because it's always positive because it's a square, this square. Well, you can also say about that squared as well. That makes sense, guys. All right, here we go. Just distribute. So 6x squared plus, I don't know what that is. 6 times 50. That's 150, and I did it 6 times, so 144. Oh man, I was all wrong. What is it? 294. Wait. Oh yeah, because it's 50, not 25 cents. 294 minus 6 times 2. And equals that to 0. All right, combine like terms. Negative 6x squared plus 294 equals 0. Yeah, I just added positive 6x squared minus 12x squared. That's a negative 6x squared, right? Negative 6x squared equals negative 294. I move the 294 to the other side. X squared equals negative divided by negative is a positive. What's 294 over 6? Is it 36? 40, what, 49? Almost there. All right. Square root of 49. Plus minus 7. You okay? Sign chart. F prime. Negative 7, 7. Give me a number to the left of negative 7. Any number. Negative 10. If I plug in a negative 10 in here, I'm just doing it in this one, the one that I'm circling. Negative 10 squared is 100. 100 times negative 6 is negative 600. Negative 600 plus 294. Negative. If I plug in a number like 0, I get 294. Do you guys see that? Positive. And if I pick that same number, but positive 10 squared is 100. 100 times negative 6. Negative 600 plus 294, again negative. Where are you increasing? Yep. F is increasing on the interval, bracket -7, comma 7, close bracket, since f prime is positive on this specific interval. Are we okay? All right, last one, guys. Last one. I'll even try to color code it. All right, you guys ready? This is f. Where is f prime positive? Whenever f is what? Okay? Where f prime is positive, and again, and I think this one assumes that you're like this, so I'm going to write f prime greater than 0 on negative infinity all the way to -1 bracket and it just says f prime positive, not bracket, parenthesis, and 1 comma to infinity. All right, f prime is negative on from what to what? Yeah, negative 1 to 1. And f prime is 0 on or at, because it's not an interval, yeah. They didn't ask where it was increasing or decreasing. They just want to know where f prime is positive. So you're positive until you reach -1, but not at -1, because at the -1, f prime is 0. You know what I mean? By the way, guys, I just want to make sure that you guys understand. You know that f is increasing on the closed interval negative infinity all the way to -1. That's a 1. With a bracket, right? Okay. I didn't hear you at all.
Why when f prime is 0, well, f prime is equal to 0, is that x equal to -1?
Because at -1 and 1, you have horizontal tangents.
So wherever you have tangents, it's like
Wherever you have horizontal tangents, right? Yeah. And 1 to infinity with a bracket on 1. You increase and decrease on an interval. The pixel right at -1 is bigger than the pixel at -1.01.
Why is this one the bracket but that one not?
Oh, but this one says f prime is greater than 0.
Oh.
This one says f is increasing. Now, if you put an equal sign on the bottom of the 0, then yeah, you can put a bracket, but it just says f prime greater than 0. Are we okay, guys? All right, guys, we're done. Now we're just going to practice a little bit. There is a little bit of delta. I haven't released it yet, but I will. It'll be like a 20-minute thing. You don't have to do it now. You can take a break. And that's it.